of the demos that we have, you can see that there is the robotic arm, there is the teleoperation station with the haptic interfaces, there is the human-robot interaction, there is some other TMS, the group, the skeleton, the wearable devices, the remote touch, the medical application. Can you see it? Okay, perfect. And the important thing that I want to tell you is the vision of our group. This is really, really important in my opinion, because it's something that we are really realizing now. So our goal is to design new paradigms of integrations between humans and robots. So mainly we want to connect humans and robots in a new way, with new paradigms, with new concepts, and we want to do this towards designing new embodied sensory motor interfaces. When for embodied you have to think about wearable, so it's something that becomes part of our body. Sensory motor interfaces because we want to read our motion and we want to write on our perception systems. Okay, so this is the mission in some way. How we want to do that? We want to do that following three main steps. So the project toward this goal is to study the human hand, because we will focus mainly on the human hand, or on the let's say also the human arm probably, but basically the upper body. And then we want to design new sensory motor interfaces which mainly observe the motion of the humans and then stimulate, write in some way on the haptic sensory modality. And then we want to invent new paradigms of human-robot integration. Is this clear, Donjun? Okay, perfect, thanks. Then, this is the project. If you take these three steps, then I will touch a few elements of these three steps. And then we will go towards the demos of the lab. Well, study of the human hand. Of course, we are approaching this from a modeling viewpoint. We know very well the kinematics of the human hand, like if they were robots. Actually, it's the same modeling of robotic arms, and we are studying the motion part and the sensory part. Just to give you an idea, this is a toolbox that we are developing, and I presented also the last time, and is really, really successful in terms of downloads. Is a toolbox where we can work with the human hand and robotic hands, of course. This is the kind of modeling. The modeling is mathematical, so we can switch between humans and robotics in a very easy way. Hand is the focus of our group. This is the mathematics. I don't want to go into this thing. What we studied that is really, really interesting as a problem was to understand, for instance, if it is better to write on the iPad with the finger or with the stylus. Is it clear, my audio, Donjun? Okay, great, thank you. So the idea, just to give you an idea of the goal of this mathematical approach, is to try to understand if it is better to write with the pen or the finger. Then we can do the modeling, of course. In this, with our tools, we can use the manipulability ellipsoids. I don't want to go, of course, into the details. This is the mathematics, a lot of algebra. We are able to dominate the algebra in some way. And then what we did is to study, to have a comparison between fingertip and pen writing on the iPad or other tablet by using the ellipsoid approach. Done. Okay? Okay. Yeah, just let me share also. I mean, I want to also to be able to see. Is it okay? Okay, perfect. Well, this was the study. Okay, so just to give an example, you see that this is the ellipsoid of velocity in terms of kinematic. So you can see that with the fingertip you have a larger space of interaction. Is it okay, Jonathan?
Now, yes.
Now, yes. Maybe we can. Maybe you can use our camera. I want to see my face also. What's going on there?
No, but it was my connection fell down.
Okay. Now I'm just trying to figure out something, but now I want to do something more. Let me try this. Let me try this. Okay. Don't you? Now I'm here. So if this is, so what we studied is to study the. Do you have a pen? Do you have a pen? Okay. We studied the manipulability ellipsoid with the fingertip and the manipulability ellipsoid with the pen. Okay. And what we realized is that the gain in terms of velocities from the joints to the velocity of the fingertip, this is, in this case, you have a lower gain, okay, a lower gain. So for a certain velocity of the joints, you have a smaller velocity of the fingertip. This is much higher gain, a very, very high gain in this case. This means that you can you see me? Can you see me? Okay, so in this case you can see that the velocity gain is much higher in this case and is much lower in this case. But this is also in terms of errors. So if you come back to the slide, and you see here, how can I remove this? I want to remove this. Okay. If you look at the slide here, you see that this is the velocity ellipsoid for the fingertip, and this is the velocity ellipsoid for the pen. This is a much high velocity, so if you want to move from an icon to another icon, then you get a better result in this case. If you want to be accurate, then this is a smaller velocity, which means also a smaller gain for errors. The errors propagate less, and you can show that this is much better. But this is just to give you an idea of what was going on. Si vedono gli luci? Okay, okay. Now, coming back to the projects. Okay, now you can see me. Okay, so now I need to share my screen again. Okay. Now, if you see in terms of the project, so this is the modeling of the human hand. Then you have the sensory motor. Then you have the sensory motor interfaces. And in terms of sensory motor interfaces, we went from grounded to wearable haptics. So you see, this was one of the first examples in my lab when we realized a demo of the grasp with the non-wearable devices. You see here you have an object in the virtual reality and the two fingers grasping this object in the virtual reality. This was, of course, non-wearable at all. We want to go towards wearable haptics, which allow us to embody the sensory motor interfaces. This is the huge project that we are running in Siena with a lot of colleagues. And the idea of wearability, this is, I really like this picture. Maybe you can follow me a little bit here. You see, if you think about the Sony Walkman, was a big step towards wearability in audio sensory feedback. And in fact, just a second, Jonathan, can you show me the face of exactly? I want to see that. Okay, great. So this is the first top image is an advertisement by Sony where they were advertising the Sony Walkman. And this was the first wearable example in terms of audio modality. The Google Glasses is the same for video. What we want to do in my project in Europe is to get the same wearability level for the tactile interfaces. So this is what we want to do. Well, done. If you look to this image is also really important. In fact, I like that I see that you are taking notes. So I think that you are enjoying this sensory transmission. I mean, this is the first experiment, don't you? Sorry for the errors. So you can see in the base on the left there is the standard Phantom, then there is the exoskeleton, and then there is our project, Wearable Haptic Interfaces. Well, you see the standard Phantom is a grounded robot. If you go from grounded robot to wearable robotics, then the simplest thing that you can get is the exoskeleton grounded on the wrist, for example. Then if you move the wrist base from the... now I want to share my face. Okay, and then I